If I were to look at the data source view, I would be able to see that the product table connects to both reseller sales and internet sales. So I would expect that products roll up into subcategories and subcategories roll up into categories so that I can see totals broken down by category. And this works correctly for reseller sales amount, but notice here with internet sales amount that I'm seeing the same value repeated each time, which indicates a problem when I do expect that I can see these amounts broken out by category. Typically, this indicates a problem with dimension usage, which is the second tab in our Cube Designer, dimension usage here. And when we look at this tab, we see all of our dimensions listed on rows and each of our measure groups listed across in columns. And at the intersection of each dimension and measure group, we can see the granularity of the relationship. In other words, employees, salespeople, sell products. So we would see employees sell products to resellers. And so the fact table for reseller sales includes an employee key column. We represent that foreign key relationship here by defining a relationship between employee and reseller sales. If we click the button here at that intersection, we can see that there's a relationship type. So essentially we're saying that there's a foreign key relationship. This yellow box represents the fact table. So we have a foreign key relationship from this fact table to the blue box, which represents a dimension. And the granularity of that relationship is employee. In other words, the employee key is what is found in the fact table, and that employee key is also found in the dimension table. So when we specify the granularity attribute of employee here, then the employee key column is the dimension column reference, and we map that to the corresponding column in the measure group. So in other words, the dimension column here is the primary key, and the measure group column here is the foreign key. Now, it isn't always the case that we have the primary key as the dimension column when we have measure groups with different granularity. For example, we could have sales represented with products with the product key, such as we do here with resellers, but we might have forecasts by category, in which case that forecast table would not have a primary key relationship to product. So for each dimension, including our role-playing dimensions, notice here we have date with due date, ship date, and order date. We all have regular relationships here, just corresponding to different columns. So the date key for the ship date dimension corresponds to the ship date key column in the measure group table. Likewise, our due date points to the due date column, and the order date points to the order date column. So that's how it knows which column to use for the relationships. And so we see relationships everywhere, except reseller sales does not have a relationship to customer. And that's correct because there is no customer key column in the reseller sales fact table. Reseller sales represents sales to resellers. If we wanted to add the dim reseller table to our DSV and create a reseller dimension, we could do that and then define a relationship. But we don't have that dimension in this particular cube. Now looking at internet sales, we see that there's no relationship with employee, and that's correct because employees don't sell products over the internet because customers are buying directly from the company. However, we do see relationships with date, with territory, or due dates and order dates. And here's the problem that we saw in the browser. When a relationship is not defined, then the top level value is what gets displayed. In other words, the grand total cannot be divided by the various categories here, or subcategories, or products. And so we fix that by creating the correct relationship. So we'll just click the button here and select the relationship type of regular. Now there are other kinds of relationships, but these are advanced topics that we'll cover in a separate course. We have a regular relationship, then we define the granularity attribute. In other words, which attribute within the dimension represents the lowest level of detail contained within the fact table. In this case, that would be product, which corresponds to the product key column in the table. And of course, the product key column corresponds to the product key column in the measure group table. And that's it. We click OK. And now, when we want to check our results, we need to redeploy the project. And then we can go back to the browser, reconnect, and here we see that reseller sales is broken down by category, as well as the internet sales is now broken down by category by correcting the dimension usage.